So we were talking about the torus, we were talking about circuits and spires. What are we really getting at with all this? What I want to make sure, ultimately what I'm going to show you, because what you can do with this number system that makes it unique is that it's infinite. It's an infinite way of, what's the word I'm looking for? It's like a diffraction grating. It's like an X-ray into reality. You can scale it from big to small. It's like a way to zoom in on reality or to zoom out. And the numbers never move. Everything I'm showing you is stationary. The functions are moving through the numbers, causing the vortices to pass vibration, but they're never, the numbers themselves are not moving or changing. They're all aspects of this eternal energy, which is a radiant energy causing all vibration and motion. It is the word, if you will. So I want to make sure that everybody understands exactly how to construct a torus. So I know we mentioned other things like layers, spires, all this stuff will come, but it doesn't really mean anything if you don't understand the very basic. So again, if you look at my colored numbers here, and then I'm going to explain this in terms of circuits. If you look at the colored numbers, those are all my positive numbers. Different color for every family number group. If you look at the black and white numbers, those are all the negative numbers. Okay? And you know, they're not in different colors for the family number groups, but I just wanted you to see clearly the negative aspect of this. So again, when a positive energy is radiating out, everything is being entrained back in negatively by the vortex. Okay? And so all you have to do to build one of these, say I start. If I know where one number is on this map, I know where every number is. That's why it's perfectly coherent. It models the way that everything is connected. It's like a crystal lattice structure. So let's say I just have a positive 9 here. I'm able to identify there's a positive 9 here. From that point, I'm going to know where every single other number is. I'm going to know by going up, it's going to be positive 1, positive 2, positive 3, positive 4. I'm going to know going down, this is positive 8, 7, 6, 5, 4. Then, since I know that my 1 and 8s are there, well, I know that moving at an angle, I'm going to have to be doubling. So I'm going to know that's a 2. And I'm going to know it must be negative because this one's positive. Then I'm going to know that's a positive 4. So I can fill in the numbers. Now I see my 4 is here by my 5, so that means there must be a 5 on this side. And then I can do my 5, 10, 15, 20. So I know where that is. As long as I have these doubling circuits, this 693, 396, and my positive and negative are moving in opposite directions. So if I have 1, 2, 3, 4 here, there's 1, 2, 3, 4 there, going in different directions, out and in. Okay, and the moving in is gravity. It's centering everything. So I just wanted to review that and make sure that everyone understood that you understood whenever you have one of these 1, 2, 4, 8, 7, 5s, we're dealing with one of these nested vortices. It can be flowing in, it can be flowing out, but notice either way, it's still got that right-handed motion. See, they're both ultimately, even though they're shearing against one another, they're moving in the same overarching direction. Even though this is going this way and this is going that way, the overarching direction is a one-way flow this way. And so what it really is multiple circuits interwoven being phased in a resonance which is highly complex, but based on this simple principle. And that resonance allows these nested vortices to function in a sequence. And when they do, you get all the qualities that you would expect of a vortex. And you can check out my advanced class where I was showing how these are really interlaced doubling circuits. It's highly significant. What that starts to do is create the phenomena of the spires. So again, if you look at one of these colors, like say the yellow, that's my doubling circuits going in. And when I have three of them together, I've got what I call a nested vortices circuit. So that's that, but across that, cutting across that, are these larger spirals, still in the same motion. Now I don't have numbers assigned to them here, but that's what this is. You can assign numbers to the vortices, and it gives them a resonance. But how do the spires work? It's really the most fascinating and complex aspect of this is looking at the spires. I'm just going to give you a little bit scratching the surface on how this works. Now, one thing I want to show you is, here's on a flat sheet of paper. I was doing some other work on this, so if you can see these tiny numbers, don't pay attention. The big numbers are what I'm talking about. But you can just take my word for it if you can't see it. These are all representing squares of 9 by 9, which I said was the smallest group you could have to make a torus. These are the nested vortice sequence orders, which I explained in my other video. Depending on how many of these groupings I have is how you understand how many spires you have, which can completely alter how you're building your torus. It brings a lot more complexity into this. The interesting thing is, though, once I assign a pattern to my nested vortices, I can continue to add blocks, groups of these 9 by 9 tiles, and I never have to change any of these numbers. They always intersect with each other perfectly. So it's perfectly scalable. From micro to macro, you can scale these. You can keep adding in numbers, and what you get is multiple different circuits. For each time you add a group of 9 by 9, you get another amount of nested vortices circuits, which are always in multiples of 3. You get multiples of 6 in your conductors, because for every nested vortices circuit, you have 2 conductors, and then there's a gap space. So you have 6 conductors going up in multiples, and you add spires in multiples of 1. Now, I may have lost everybody with that, but I think some of you may follow me. So let's look at it on a flat piece of paper and see, even though this is tiny, don't worry about seeing the numbers. All you have to just see is the color pattern. Okay, so here is a 9 by 9 on a flat sheet. If I connect the ends on either side, I have unbroken multiplication series. So my 1 and 8s are my vertical, my 4 and 5s are my horizontal. I have doubling circuits moving at angles. Okay, so I have all those principles. I have my family number groups all spread out. I don't have any more of any one number than any other number. Everything's in equal proportion. So to me, I'm making a true torus. I have a binary flip-flop that's perfect. So I'm making a torus. It's composed of 3 nested vortices circuits, which is 6 different conductors. And the vortices are 18 vortices again, and they're in 3 groups of 6. But there's only one spire. The reason why I've colored this all in red is because even though there's 18 vortices here, if you go across the vortices at an angle, which you'll see more easily in these other ones, they're all connected to one spire. So for a 9 by 9 torus, you have one spire. Now, as I expand this out, I want you to take into account that I'm also doing the inverse square law, which is really important in mathematics. Also, the regular doubling circuits are modeling the inverse square law. It's what I initially did for you on the symbol. But now I'm doing the inverse square law in numbers of 9 by 9 torus groupings. So in other words, if this is 9 by 9, this is going to be 18 by 18. So where I have 1 square here, I have 4 here.